Hey guys, I'm kind of hungry. It's about a bit after lunchtime, and I'm I'm gonna eat something that my favorite food, burgers. All right, I really wish I had a real burger, but I really don't. This air burger is kind of tasteless. So what I'm gonna do? That's a really crunchy burger, air burger. No, this air burger does it a lot better. Why? Because I added salt to it. Now, we all know what a salt is, right? Sodium chloride. But in chemistry, in the world of chemistry, there are basically many other types of salts. But what do we define a salt as? A salt is basically a metal and a nonmetal combined together, right? So here are some examples of salts. Chalkboards. When you were growing up, you may have some teachers that wrote stuff on a blackboard with that chalky thing, right? Well, chalk is basically a type of salt called calcium sulfate. Well, another type of salt are fertilizers. Like if you like to help your parents to grow some plants, like I love to grow jalapenos and put them on my burgers. Fertilizers, basically another type of salt, ammonium nitrate. And we have another type of salt that are called limestones. Now, if you travel to Europe or maybe some old European kind of place, you may have come across statues made of marbles, you know, like, yeah. So these are limestones, and they're basically another type of salt called calcium carbonate. And then we know our regular favorite friend, sodium chloride, and its healthier cousin, potassium chloride. All right. So, in a lab, there are basically three methods to make salts. The first way is to mix metal and acids. The second method is to mix metal carbonates and acids. Now, metal carbonates are basically like another type of salt, but so you're just taking like one type of salt and making another salt. But anyway, that's what it is. And finally, when you mix acids and alkalis together, you make another type of salt. And this process is called neutralization, which we'll talk about later. All right, here we go. So, acids. Basically, there are three types of acids that you kind of have to know in this class. Hydrochloric acid, sulfuric acid, and nitric acid. The symbols are HCl, H2SO4, and HNO3. When acids are dissolved in water, anions will be formed. Anions are simply negative ions. The anions are chloride, sulfate, and nitrate. All right, you gotta kind of remember this because this will help us when we generate our word equations. All right, here we go. General word equations. When you mix acid with a metal, you make salt, and a byproduct called hydrogen. You know that you made hydrogen when you put a lit split, which is basically a piece of lit wood. You put the split over the reaction vessel like a conical flask, you will hear a pop sound. Wow, I'm not really good at that. I guess. Anyway, so that is what you get. So here are a couple of examples. Hydrochloric acid and zinc. Well, what you get is zinc chloride and hydrogen. Zinc chloride, and hydrogen. I'm just going to shortcut this to write H2. Zinc chloride is your salt. What about if you mix sulfuric acid with magnesium? You get magnesium sulfate. Sulfuric gets sulfate, right? Magnesium sulfate. And hydrogen. There you go. Easy peasy. But remember our reactivity series and we did our observations? Some metals don't react with acids, like copper, silver, gold. What do you do about them? Well, a way is to turn the copper, silver, or gold into their oxides. So for this example, we have sulfuric acid and copper oxide. So when you mix them together, you should get copper, sulfate, and water. Here we go. Copper, sulfate, and water. H2O. So there we go. Metals and acids. Now, what about making metals from carbonates? Salts from carbonates. The general word equation is acid with a metal carbonate will give you salt, water, and carbon dioxide. Now, how do you know carbon dioxide is made and that you have successfully made salt? Well, another way, the same way is to use this lead splint example. You take a lead splint, put it over the mouth of the reaction vessel, and the splint should just die off. Why? Because carbon dioxide displaces the oxygen in the air, and then without oxygen, the splint would not stay lit. Anyway, here are two examples: sulfuric acid and calcium carbonate. Ooh, limestone. So when we put them together, this is what we'll get. We'll get calcium sulfate, right? Because it's from sulfuric acid, plus water, plus carbon dioxide. Cool? What about hydrochloric acid with copper carbonate? Well, you should get copper, chloride, chloric will mean chloride, copper, chloride, and water, and CO2, carbon dioxide. Great. So finally, we have a third way to make salt, which is to mix equal proportions of acids and alkalis in a process called neutralization. Neutralization. Okay, here's the word equation. Acid and an alkali will make salt and water. And here's our example. Classic example. Hydrochloric acid with sodium hydroxide. So you get sodium, chloride, and water. So, there you go. And another note about acids and alkalis and the neutralization process is that in the lab, neutralization is usually done by a process called titration. Titration. Basically, a titration is mixing acids and alkalis. Here. First, most likely in a class lab, you will have an unknown concentration of an alkali. You put that unknown concentration of that alkali into a beaker or conical flask, a known volume of the alkali into the conical flask. And you put the acid in a burette, which will look like this. Okay? Fill it up the acids to the top until you reach the 0 point mark, and then you put a couple of indicators into the reaction vessel, and then what you're going to do is you are going to titrate by adding drops of acid into the alkali. And once the reaction vessel changes color, you would know you have reached your neutralization step. There's a more technical term to it, but we'll talk about that in year 10 or something. Okay? So, that is titration. And finally, to cap this all off, just to remind you, alkalis are nothing but dissolved bases. Now, bases don't really react because they're usually in the form of a solid. Alright? So when you put bases like metal oxides and water, you make alkali. An example would be sodium oxide, and you put it into water, you get sodium hydroxide. But some metals, again, don't really react with alkalis because some metal oxides don't really react with water because they are insoluble in water. That means they do not dissolve in water. What that happens is that you take your metal oxides and then you mix them with acids. Just like this. Okay, that's it.